This is part 1 of the series Reasoning and Proof. And it's in this series that we're going to be investigating the things that distinguish geometry from pretty much every other form of mathematics you've studied to this point. And one of the primary aspects that makes geometry different from everything else is we're very concerned with why things work the way they do, not just how they work. We're not just going to be looking at formulas. Algebra is the basic underpinning for everything we do here, but we need to be able to show that all the ideas are provable, that we know where they come from and why they work the way they work. And that's the essence of reasoning and proof. And so that's what makes this look so much different than every other form of mathematics. And some people embrace that, and some people find that a very difficult aspect to handle. But in either case, I would recommend that you start this with an open mind and see how you can adapt this to your current thinking process. Now, to begin with, the underpinning of reasoning and proof is an idea called conditional statements, where you've seen these many times in the past. A conditional statement is simply a statement that presents a condition and some conclusion that would be based on that condition. So a conditional statement, the definition of it is a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. Now, conditional statements are very often written in if-then form, and that's the way you may be familiar with seeing conditional statements in the past. So here we have a conditional statement. The hypothesis is the part of the statement that follows the if. So if you study, so this is the condition or the hypothesis, the idea that forms the basis for your conditional statement. Then a conclusion, then you will pass the exam. So if you study, then you will pass the exam. Now there's an idea embedded inside here of a truth version of this statement. So if you study is true, then it's also considered true that you will pass the exam. This is a statement saying if this is true, then this will also be true. So cause, effect, hypothesis, conclusion. Having said that, truth is not a requirement for generating a conditional statement. You could have a conditional statement that is completely and totally false, but it's still a conditional statement. And we're going to deal with truth and false later when we deal with conditionals and logic statements, but we're going to do that a little bit later. For now, we're worried about the form of the conditional statement. So you could come up with something that says, if I jump, then I will fly to the moon. Well, that's obviously not true for most of us, but it's still a valid conditional statement. You have if, condition is you jump, then the conclusion is you will fly to the moon. It's not true, but it's still a valid conditional statement. Now, when we deal with conditional statements, we're also going to have to contend with the idea of logical symbolism. And the way you would state a conditional statement in its logic form is if P, then Q. P denotes the hypothesis, Q denotes the conclusion. Now there are various reasons for why we chose Q and P for the hypothesis and conclusion, but suffice it to say that those are the traditional symbols that we currently use for hypothesis and conclusion, and leave it at that because it doesn't really add much to the discussion here. So if P, then Q. The arrow means then. And so this is how we're going to look at our conditional statements from this point forward. Now, one of the first things we're going to need to know about is the idea of negation, to negate a conditional statement. So let's take a look at negation. To negate a statement means we basically take the negative of that statement. So an example here for our first conditional would be if you don't study, then you will not pass the exam. Now there are many different words you could have used to indicate the negative of this statement up here. But the idea is to negate the hypothesis, you would take the negative. So you study is the positive, you don't study is the negative. Or you could have said you won't study, or something indicating the negative. Then you will pass the exam. The negative is you won't pass the exam, or you don't pass the exam, or however you wish to say that. So negation is to take the negative. Now the logical symbols for negation, you precede the element that you're going to negate with a tilde. So this is not P implies not Q, or you could say not P then not Q. So this arrow means implies or then. The statement is read, if not P, then not Q. So read this as not. So this is not, negate. Now there are four fundamental forms of conditional statements, and those are what we're going to focus on next. And we're going to use one particular conditional statement for all of those forms just so that you have a basis for comparison. So let's take a look at the four forms of conditional statements. The first form is what we said before. It's the if-then form. If hypothesis, then conclusion. The logical symbolism is if P, then Q. So here's our example conditional. If you have an apple, then you have a fruit. All right. So we just take this as a conditional statement, if hypothesis, then conclusion. The next form that we're going to have is the converse. In the converse, quite simply, we simply swap the hypothesis and conclusion. So note that the fruit goes over here and have an apple goes over here. So they just swap places. So converse, we just swap them. The P goes to where the Q is, the Q goes to where the P is. So when the hypothesis and conclusion are swapped, we have the converse. Now you can come up with a convenient way to remember that. That's great, but converse generally means to swap meanings, to reverse meanings. And don't think of reverse as negate, because that's what we're going to talk about next. So first one, conditional. Second form, converse. The third form is the inverse. And the inverse is not. And that's actually not a bad way to try to remember it. If you think of the inverse, you can think of inverse is not. Is not. Inverse is not. So we take the negative of both the hypothesis and conclusion for inverse. So think is not. So the statement would then be, if you have an apple, that the inverse is if you don't have an apple. Then you have a fruit. The inverse is then you don't have a fruit. So the inverse of this complete statement is if you don't have an apple, then you don't have a fruit. Notice the hypothesis is still in the same position. It stays the same. So the hypothesis is still here, and the conclusion is still here. So these haven't moved. This is still the hypothesis. This is still the conclusion. And the fourth one is a combination of both the converse and the inverse. This is called the contrapositive. The contrapositive is the converse of the inverse, or you could say it's the inverse of the converse. And the logic statement for the contrapositive is, if not Q, then not P. So let's look and see what happened here from the original. We took the Q and we swapped it. The Q went to where the P is, and the P went to where the Q goes. And we also negated them. So swapping the P and Q was the converse. Negating them is the inverse. So that's why we say it's the converse of the inverse or the inverse of the converse. Now to take a look at the statement, if you have an apple, then you have a fruit. Well, the conclusion will go to where the hypothesis is, and the hypothesis would go down to where the conclusion is. So if you don't have a fruit, then you will not have an apple. Or then you do not have an apple. So that's contrapositive. And notice the conclusion comes over here, and the hypothesis comes over here, and we negated the conclusion, and we negated the hypothesis. So, not P, not Q. All right. Let's work an example and see if we can come up with the 4 statements. In this example, we have all dogs have 4 legs. This is clearly a statement that is not in if-then form. So our first task is to convert this statement into if-then form. Now we can clearly see that this is a conditional because we have a subject and we have an object. The subject is going to be our if part, our conditional, and our object is going to be the 4 legs part, or has 4 legs part. So I want you to go ahead and see if you can turn this into a conditional statement. So go ahead and pause the video, try to generate an if-then form, and then replay and see if yours matches mine. Okay, so the if-then form would then be, I got, if it's a dog, then it has 4 legs. You could have said, if the animal is a dog, then it has 4 legs. Now you have to be really, really careful with forming conditional statements. Don't add any more information than is given to you. Don't get confused by the fact that we're dealing with English statements here. These statements are not to be interpreted literally, and that's one of the biggest mistakes people make, is they interpret these English statements to try and make sense of them. Think of these strictly from a form standpoint. Don't worry about its truth. Don't worry about its falsehood. Don't worry about whether it makes sense. We're simply worrying about having an if statement, having a condition, having a then statement, and then a conclusion. Doesn't matter whether these guys make sense. Try and get that away from your thinking process. Don't try to make sense of it. And the reason is because we're going to be dealing with geometric terms, which are much more abstract than these subjective terms that we're dealing with here in English. Let's go ahead and see if you can come up with the converse of this statement. Pause the video. All right, my converse is, if it has 4 legs, then it's a dog. Hypothesis goes to where the conclusion is. Conclusion goes to the hypothesis position. If it has 4 legs, then it's a dog. Just swap the hypothesis and conclusion. All right, now try inverse. Pause the video. Okay. The inverse should be, take the negative of these statements. If it's not a dog, then it does not have 4 legs. Then it does not have 4 legs. And now finally, let's go ahead and do the contrapositive. Pause the video. And the contrapositive would be, we would take the converse and invert it, or take the inverse and take its converse. Doesn't matter which one you do. In either case, we're taking the hypothesis, moving it down to the conclusion, moving it to the hypothesis, and negating them. The way I form these is knowing that I have to swap. I just look at this and say, okay, my first piece is going to be this, and I have to negate it. So if it doesn't have 4 legs, I just look at this and say, if it doesn't have 4 legs, that's what I write first, then it's not a dog, and I write that second. That's the easiest way for me. Come up with a method that you're comfortable with, and you're good to go. All right, let's move on to our next set of topics, and we'll do that in the next video, and so I will talk to you then.